Hi there, welcome to my video where we're talking about the relationship between hydronium concentration and pH, and we're going to figure out how to calculate each of them. So the pH scale is basically a scale that shows the acidity of different objects. So every time I move up one pH, that's saying that it's 10 times more or less acidic than the thing next to it. So anything less than 7 is an acid, and everything greater than 7 is a base. And my example here is looking at my pH scale. So if I was going to draw my pH scale, so it goes from 0 to 14. If I was going to actually fill in the numbers here, so 7, remember, is neutral. So if I went from 5 to 2, I would have to go 1, 2, 3 times. Because it says that it's a change of 10 times, you would say that that pH change is 10 to the 3, which is 1,000 times. So the pH of 2 is 1,000 times more acidic than the pH of 5. Okay, and that's how that scale works. So when we're calculating pH, we can use logs, which is a button on your calculator because it has this property of moving up these certain amounts of times. So when we look at the pH value, it's actually telling us basically the concentration of the dissolved hydronium ions. Remember that hydronium ions are this molecule right here. That is a hydronium ion, H3O positive. And this formula, these two formulas can be found on page 11 of your data book in case you're wondering where they are. So let's actually look at some examples, but before we look at some examples, we have to really make sure that we're doing the proper significant digits for our pHs. It's different depending on if I give you a pH or if I'm giving you a hydronium concentration. So this one's super important to remember. If you don't do these right, you're not going to get any of the questions right, unfortunately. So if I have a pH and I am putting it into a hydronium concentration, the first thing I need to look at is how many decimal places are in the value. So if I have this pH, I only have the 2 and the 1. The 2 and the 1 are my decimal values. So that means I have 2 decimals, which means that my answer when I put it into hydronium concentration needs to have 2 significant digits. Okay, my hydronium concentration, on the other hand, I have to look at the whole number. Okay, so I have 2.71, which has 3 digits in it. Okay, and 3 digits in a pH would translate to 3 decimals in my answer. So it's kind of wonky and weird because I have to go from significant digits to decimals and then back. Okay, if I have a pH, again, I'm just looking at the amount of decimals. I have 4 decimals, which means my answer will have 4 significant digits in it. Okay, so I'll kind of practice these rules with you as we go through and look at them. So let's actually do some questions. All of these questions I'm going to be solving for the pH. So the first thing that I like to do is look at my numbers and figure out how many decimals do I have to have in my pH. So in this question, I have 1.41. Those are 3 significant digits, which means that I'm going to need to have 3 decimals in my answer. Okay, when I do that, okay, that kind of just eases off the pressure and I can just do this question without having to really think about it at the end, how many decimal places I need. I have it there now off to the side for myself. Okay, the next thing I'm going to do is write my formula. So when I'm looking for a pH, I have to use the formula negative log of the hydronium concentration that I'm given. So that's the formula that I use. So for this first example, my pH would be equal to the negative log of 1.41 times 10 to the negative 3. So when I do this in my calculator, it's going to look a little bit different because I actually need to type it in properly. Okay, so when I type this in, I want to do the negative and then the log button. And then in brackets, I'm going to put my scientific notation number. So I have 1.41 second function e to the negative 3, because that's my scientific notation number. And then when I press enter, I get this really long decimal, 2.85078, blah, 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 blah. So if I go back to my question, okay, remember before I said that I had to have 3 decimals? Okay, my answer here was 2.85 blah, 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 blah. And I should get 2.851 as my answer. pH does not need units, it's just a number, but I just have to make sure that it has the correct number of decimals. I said that I had to have 3 decimals, and this has 3 decimals for myself. So I've done this question correctly. Okay, the next question, I'm going to go, my pH is equal to negative log of 0.4 times 10 to the negative 11. Okay, and remember this has 1 significant digit, so I'm going to put 1 decimal in my answer. Okay, so for this second question, I'm going to go negative log of 0.4, second function e, and negative 11. Remember, that's like my quick way of doing my exponent so I don't make any little mistakes. And I'm looking to have 1 decimal place. So my answer would be 11.4 because I have to round this up. So my answer here is 11.4. Remember that pH does not have a decimal. It's just a number. I just have to make sure that it has 1 decimal because I had 1 significant digit in my hydronium concentration. So for number 3, this time I have 4 values in my number. 4 values mean I have to have 4 decimals. So I'm going to go pH is equal to the negative log of 15.12. And that's what I'm going to type into my calculator. Okay, so we go negative log of 15.12. This number is not scientific notation, so I don't have to worry about the fancy E button. And then I just press enter. Remember, this one had to be 4 decimals. So I'm going to say negative 1.1796 as my answer. Okay, remember that pH does not need any units. It is literally just a number. I just have to make sure that it has 4 decimals because I had 4 numbers here, making sure that it's correct. Okay, so this set of questions, I'm going to be looking at the pH, and I'm trying to find the hydronium concentration. So for my hydronium concentration, my formula is going to be 10 to the negative pH. So for this first question, first of all, I have 2 decimals, 1 and 7. So I'm going to have 2 significant digits in my answer. Okay, and my question itself is going to be 10 to the negative 9.17. Okay, so I'm going to go and type that into my calculator. So easiest thing to do is go second function, and the log button brings us to times 10 to the something. And then I'm going to go, it was times 10 to the negative 9.17, because that was my pH. It has to be negative pH. And my answer here is this number here. Okay, remember that my answer in pH had 2 decimals, so I have to have 2 significant digits. So I would say 6.8 times 10 to the negative 10 is my answer. This time it's in moles per liter because I'm looking at a concentration. Okay, the next question, I have to go, my hydronium concentration is equal to 10 to the negative pH. So it would be equal to 10 to the negative 0.450. And while I'm here, let's just look. It has 3 decimals, so that means that I'm going to have 3 significant digits in my answer. Okay, I'm going to type in 10 to the negative 0.450. So second function, log button brings us to 10 to, and I go negative 0.450. Remember, it has 3 decimals, so I need 3 significant digits in my answer. And I would say my 3 significant digits would be the 3, the 5, and then I'm going to round this to a 5. So I would say my answer is 0.355. And those are 3 significant digits. Make sure you put moles per liter as your answer, because that's the units on concentration. And make sure that you have the proper number of significant digits. I have 3 decimals in my pH, so that means I had to have 3 significant digits. Okay, again, it's just saying that in this example, it would also be 3 decimals. Okay, just the way that it worked out. It's not a scientific notation number, so that is okay to leave it like that. Okay, you can now do the next question. So this question, I have 4 decimals. I'm going to need 4 significant digits in my answer. Okay, remember that hydronium concentration is equal to 10 to the negative pH, which is 14.8957. So that's what I'm going to type into my calculator, and just remember that I need 4 significant digits in my answer. So I'm going to go second function log button, 10 to the negative 14.8957. And remember, I need 4 significant digits in my answer. So I would say 1.271 times 10 to the negative 15 is my answer. So 1.271 times 10 to the negative 15, and then make sure that you put moles per liter. Okay, last question here. We're looking at all 4 of these numbers, and we're going to put it into the order of least acidic to most acidic. So for this, we don't actually need to change number 2 and number 4 because those are already in pHs. We just have to change this to a pH and this to a pH. So we actually only have to do 2 calculations for this. Okay, remember that if you're looking for a pH, you have to go pH is equal to negative log of the hydronium concentration. So for this example, I would have to go negative log of 4.2 times 10 to the negative 3. So that's what I'm going to type into my calculator. Negative log of 4.2 times 10 to the negative 3. Close my bracket, press enter. Okay, I got 2.376750, blah, blah, blah. So in my question, I was giving 2 significant digits because I have 4 and 2. So I need to have 2 decimal places. So I would say 2.38 is my answer. Okay, so now moving on to the next question. Remember, the pH for question 2, I don't have to change. The pH for question 3, I do have to find. So I would say that I would go negative log of 5.7 times 10 to the negative 10. That's what I'm going to type into my calculator. Negative log of 5.7 times 10 to the negative 10. And I was given 2 significant digits, so I'm going to be looking at 2 decimal places. So I would say my answer is 9.24. So 9.24. And then I have to put it in the number from least acidic to most acidic. So least acidic would be the highest number, farthest away from 7. So that would be number 3 with 9.24. Then the next highest is number 2, and then 1, and then 4 is a negative number. So I'm guessing that would be the least acidic because it's even farther on the opposite side of 0. So the answer would be this.